If a wire is moved through a magnetic field, a voltage will be induced across its ends. If the wire is part of a complete circuit, then a current will flow. We call this effect electromagnetic induction, the generation of electricity by movement through a magnetic field. If the wire moves down, the direction of the induced current reverses. If the wire is stationary, no current flows. If the wire moves along the field line, no current flows. The wire must cut the magnetic flux lines to induce a current. A current can also be induced in a coil of wire in the same way. 1. Either moving the magnet or the coil induces the same current. 2. Reversing the motion reverses the direction of the induced current. The size of the induced current can be increased by 1. Increasing the speed of movement. 2. Increasing the strength of the magnet, more flux lines. 3. Increasing the number of turns in the coil. In summary, the size of the induced voltage and current depends on the rate at which the flux lines are cut. The simple alternating current generator, dynamo. As the coil rotates, its sides cut field lines. An alternating current flows through the lamp. Each time the coil rotates once, one complete cycle of AC voltage is induced. The period of the waveform is the time it takes to generate one complete wave. The period t equals 0.02 seconds. The frequency of the voltage waveform can be calculated using the formula frequency equals 1 over period. F equals 1 over t. The frequency of this voltage is F equals 1 over 0.02, which equals 50 Hz. This is the frequency of the UK's main supply. This AC voltage has an amplitude of 4 volts. The transformer. The transformer consists of 2 coils of copper wound on a laminated soft iron core. The action of a transformer. 1. An alternating voltage is applied to the primary coil. 2. An alternating current flows in the primary windings. 3. Primary current sets a change in magnetic field in the soft iron core. 4. The other coil is called the secondary coil. 5. A continuously changing magnetic field cuts the secondary windings. 6. An alternating voltage, Vs, is induced across the secondary coil and an alternating secondary current flows, Is. Use of a transformer. The great importance of a transformer is that it can be used to change the size of an alternating voltage. The voltage appearing at the secondary coil can be calculated using the turns ratio equation, Vs over Vp equals Ns over Np, where Vs equals secondary voltage, Vp equals primary voltage, Ns equals number of turns in secondary, Np equals number of turns in primary. Step-up transformer. Here, Ns is greater than Np. The number of turns on the secondary is greater than that on the primary. The output voltage is bigger than the input voltage. The turns ratio is 4. This means that the secondary voltage is 4 times the primary voltage. Step-down transformer. Here, Ns is less than Np. The number of turns on the secondary is less than that of the primary. The output voltage is less than the input voltage. The turn ratio is 1/4. This means that the secondary voltage is 1/4 of the primary voltage. Energy losses in a transformer. Over the years, the design of the transformer has changed to make it more energy efficient. Ideally, it should waste no energy. Features employed to do this include a laminated soft iron core to reduce heating losses, thick low-resistance copper coils. Today's design techniques make transformers virtually 100% efficient with no energy losses. Power in equals power out. Vp IP equals Vs Is. For the step-up transformer, The secondary voltage is 4 times the primary voltage. Vs is greater than Vp. The secondary current is only 1/4 of the primary current. Is is less than Ip. For the step-down transformer, the secondary voltage is 1/4 the primary voltage. Vs is less than Vp. The secondary current is 4 times the primary current. Is is greater than Ip. The national grid. In a fossil fuel power station, the fuel is burnt, converting stored chemical energy into heat energy. The heat is used to produce high-energy steam, which drives the turbines. The turbines produce kinetic energy. The kinetic energy is converted into electrical energy in the dynamo. This electrical energy is distributed around the country by the national grid system. This is a system of cables and pylons that connect houses, factories and offices all over the country. The energy lost as heat in the cables would be considerable at high current. A step-up transformer is used to produce high voltages of 132,000 volts or greater for transmission to the grid. This keeps the current in the wires very low. Step-down transformers then reduce the voltage for use in homes, factories, schools and offices. Vital point: a transformer will only operate using AC voltages as it requires a changing magnetic field. This means that our main supply is AC.